In this video, we're going to discuss monohybrid crosses. Monohybrid crosses are crosses involving a single trait, monohybrid, and in the single trait, one allele will be dominant over the other. Good examples of monohybrid crosses are all of the traits that Mendel studied in his pea plants, where one trait was dominant over the other. Yellow pea pods were dominant over green pea pods. Tall people are dominant over short people. Now, in the real world, simple cases of genetics like this are rare, but it's important for us to start with these basic problems. You're going to have three possible genotypes and two possible phenotypes. So remember, phenotype is the physical trait, so we can have people that are tall and people that are short. And then genotype are the actual allele combinations you can have. So we can have a homozygous dominant tall, a heterozygous tall, or a homozygous recessive short. So let's go through and do some of these problems. Remember to always read the problem first and follow the basic genetic rules. So we're going to assign letters, determine the parent's genotype, and then solve using a Punnett square. So for this problem, it says, in dogs, wire hair is dominant to smooth hair. So I'll make my key. Wire hair is dominant to smooth. In a cross of a homozygous wire-haired dog with a smooth-haired dog, what will be the genotype and phenotype of the F1 generation? So I'm crossing a homozygous wire-haired dog. Homozygous means two of the same alleles for wired hair. Crossing that with a smooth-haired dog. It doesn't have to tell me homozygous or heterozygous. I know it has to be homozygous recessive because this trait is recessive. So we did the key and the parents. Now we'll solve with a Punnett square. Put one parent on one side, the other parent on the other, and go through and fill that Punnett square in. So we see that in the F1 generation, the first generation of children after the parents, we have 100% heterozygous for genotype and 100% wire hair for phenotype. Let's try the next problem. Wood rats are medium-sized rodents with lots of interesting behaviors. You may know them as pack rats. Let's assume that the trait of bringing home shiny objects, big B, is dominant to the trait of carrying home only dull objects, little b. Suppose two heterozygous individuals are crossed. How many of each genotype would be expected if only 4 offspring were produced? So at this point, you should pause the video and fill in the Punnett square and see if you get the same answer that I get. So we're going to expect 25% homozygous dominant, 50% heterozygous, 25% homozygous recessive. So if only 4 offspring were produced, we'd expect that is not correct. We would expect 1 homozygous dominant, 2 heterozygous, and 1 homozygous recessive, just breaking it down by those percentages. Did you get that same answer? In mice, black fur is dominant over white fur. If 2 mice are crossed and produce all black offspring, list the possible genotypes and phenotypes the parents could have. So notice I'm still doing my key with the uppercase letter for the dominant trait and the lowercase letter for the recessive trait. Now this problem is a little different because it doesn't give us the parents, so we have to work backwards. If all the offspring are black, what that tells us is that they all are going to have at least 1 dominant allele. Because by now you should understand that a homozygous dominant mouse would be black and a heterozygous mouse would be black. So we can work like this and work backwards just using these blanks to remind us that it could be homozygous dominant or heterozygous. So This combination would fill in the Punnett square, giving us all black offspring. However, we could change a letter and still get all black offspring. Now, sometimes these problems you have to think through many different options to find all the possible combinations. What if we did this? Now, that wouldn't work because this box would no longer have a big B. What if we tried this? Again, that combination would work because we'd have all black offspring. Here's another problem you can try. In humans, earlobes are either free or attached. The free earlobe is completely dominant over attached. Free is dominant over attached. Again, notice I'm using an uppercase and a lowercase letter, and I'm using letters that look different. It would not be a good idea to use a P, for example, because once you start working in the problem, the letters are going to start to look the same. A man with free earlobes marries a woman with attached. Now notice again, just like on the last problem, I'm using this blank because a man with free earlobes, we don't have enough information about him yet to know if he'd be homozygous dominant or heterozygous. So I'll keep reading in the problem. Of their 4 children, 1 has free earlobes and 3 have attached. So 1 has those free earlobes. Again, we don't have enough information. And, hold on, I don't want to use an X there because that would imply that they're married. There's 1 that's free earlobes and then 3 that have attached earlobes. Give the genotypes for the man, his wife, and their children. So now the problem is asking us to go back and figure out the specific genotypes. Now if we think about the rules of genetics, your alleles have to come from somewhere. So these children right here, little f, 1 little f must have come from their mother, and 1 little f must have come from their father. Well, that makes sense for the mother, since we can see right here that she has little f's to donate. However, since we had the blank in the father, that'll help us fill in the information, because we know that little f has to come from the father as well. Along that same train of thought, for this child here that has attached earlobes, we know that the big F could be donated by the father, but we know since the mother only has little f's to donate, that that individual must be heterozygous. Okay, one last genetics problem for the monohybrid crosses. In humans, having a widow's peak is recessive to a normal hairline. Cross a woman who has a straight hairline, whose mother had a widow's peak, with a man who is homozygous recessive for the trait. What are the genotypes and phenotypes of the offspring? At this point, you should be able to pause the video, solve the problem, and see if you get the same answer as me. Did you pause the video and end up with the same answer that I have? One question you might be wondering is how I knew the genotype of the woman, since it just says that she has a straight hairline. But the problem does tell me that her mother had a widow's peak. If her mother had a widow's peak, she must have been homozygous recessive and only had little d's to donate. So that lets me know that the woman must be heterozygous. Go ahead, fill in that Punnett square, and you should find 50% of their children would have a normal hairline and 50% would have a widow's peak.